what is the level of compilation happens for a high level programming language. As we know, we will be writing the code which is so called in form of high level language. Okay. So initially our code will be in whatever be the language what we are doing. Suppose n.cpp. If we are typing in cpp, that will be the high level form. Okay. So the first conversion happening is from high level to the assembler or assembly code. Assembly level language. From there it will go to machine level language. Okay, we will see the conversions. Okay, so initially we have a high level language. Okay, that high level language will be converted to a machine level code. Okay, and whatever be the high level form or whatever be the thing what we are converting is called as the source code. For example, if we are converting high level language, this is the source code, and the conversion, if we are converting it from high level to machine level, okay, with compiler, then this high level language is the source code and machine level language is the object code. Okay, the same way the same conversion can be done using interpreter also. Okay, so compiler and interpreter are same. Compiler and interpreter are same. The difference is, for compiler it will compile the whole code at the same time. The whole code will be converted or compiled at the same time. But interpreter will do interpreting one by one. Okay, it will take the lines one by one and do the interpreting. That is the difference between these two, but both are doing the same function, and according to the execution time it takes, compiler is more faster than interpreter. Okay, now we will see what is an assembler. So the next kind of interpretation is assembler. Assembler level interpretation. So this assembly language will be converted or will be turned to machine level language. Okay, so from higher level to assembler language, how using assembler, and from assembly language, this assembly language will be with the extension ASM. Okay, so whatever be the thing which we convert is called a source code. So this is also a source code, and the output what we obtain is object code. Okay, finally after the assembler conversion, whatever be we get is called as the executable file. That executable file will be having the extension exe. Okay, so this file will be the executable one. Now this is now we saw what is compiler, what is interpreter, what is an assembler. Okay, now next we will see what is a linker and what is a loader. Now next is linker. Linker in the sense, Suppose I have a source code 1, this is one source code, and I have another source code. Okay, the first source code is converted to the object code, object file. The second also converted to object file. So linker, what it will do, it will link both of them together and it will generate a single object code. So this operation is done by, or this function is done by linker. Two source codes, individually we will get the object code for each of them. Then using linker we will join both the object codes. That is the functionality of a linker. Now next we will see what is the function of a loader. Next is loader. Loader means finally we obtained the object file, that means the one is executable. Okay. So loader, what it will do is, we have this object file, we have the RAM and we have the processor. Okay, we have the processor, we have RAM and we have this object file which is executable. So this object file will be loaded to RAM. Before it goes to processor, it will be loaded to RAM by loader. That is the process of, or that is the function of loader. It will load the object executable file to RAM. From RAM it will be passed to the processor. Okay, it will be loaded to the processor. Okay, that is the functionality of the loader. Next is debugger. Debugger means, first of all we should know what is a bug. Okay, so bug in the sense, while executing a code, sometimes that each line, if we go through each line, we couldn't find any kind of errors or mistakes in the code, but still it shows a wrong output, means we have to interpret each line by line. There can be some data type, a difference in the data type, or can be some particular parsing problem. Okay, so we should identify what is that particular problem. Okay, so the problem is called as bug and identifying the particular problem is called as debugging. Okay, an example of debugging I'll share. There is a video how to debug a particular issue. So that is a Python code. Okay, they have used the compiler PyCharm. They are showing how they are rectifying a particular problem in a program. So that program is like, they have written the program for adding two numbers. So while passing numbers 2 and 3, it shows the answer as 23. So what was the problem is, they goes through line by line and they are finding out the issue. So they found out the variable or the data which passes is treated as a string. Okay, so it is not taken as an integer, instead of that it is taken as a string. So while doing addition, 2 is a string according to that program. So 2 is added with 3, so it gives the result 23. This is how that output came. So what we have to do, so we should identify that. Okay, then we need to convert that each of that variable to integer. So this is how they have done. That video I'll share. Okay, that is simply what is debugging. The next we will see what is an emulator and what is a simulator. These two are very interesting concepts. Like emulator means, for example, for a flight, initially they will make a prototype of a particular flight to test the working. So that is an emulator. That means that particular prototype will exactly, it will exhibit what is actually that flight has to be. So, that is an emulator. Emulator means it is exactly as something, and that will obeys all the rules of the original property or the system. That is an emulator, but it is not the actual thing, but it is exactly as similar to the actual system. And what is simulator? Simulator means it mimics or it exhibits what is some particular system, but it will not obey all the rules. That is a simulator. We have lots of simulator available. For example, we have BookSim is a simulator. BookSim is a simulator. Actually, there is for executing C++ program, network on chips kind of area. There is area called network on chips, and that particular area programming will be done in the simulator called BookSim. BookSim is actually that program has to be evaluated with some benchmarks and all for checking the precision of the code, but this BookSim is just a simulator. It does not have any benchmarks to evaluate the correctness of the code, but it will be working as a normal compiler for NOC, network on chips. So, like that. So, it mimics as an actual system, but it does not obey all the rules of a particular system, but still we can use it as a a temporary arrangement. Okay. So, that is a simulator, not the exact thing, but it is somewhat similar to the actual system. That is simulator, the difference between simulator and emulator.